welcome back to the video lecture series on pattern recognition. This is Josna Devi Bodapati, Assistant Professor, CSE Department, VFSTR. So, in this lecture series, in the previous lectures, we have discussed what pattern recognition systems are and what are various real-time applications of pattern recognition and what are the kind of real-time problems we could solve recently using these pattern recognition algorithms. And in today's lecture, so I'll briefly explain what are the various stages of the pattern recognition systems and what are the various types of problems that can be solved using pattern recognition algorithms and what are the types of pattern recognition algorithms that are available for the usage. The agenda of today's lecture is, so we will see a few of the real-time applications of pattern recognition, then different stages of the pattern recognition systems in detail and what are the different types of learnings that are possible and unsupervised, supervised and the semi-supervised learnings are. So, in addition to that, we will have a glimpse of what reinforcement learning is and what is the difference between classification, clustering and regression. So, for what kind of problems, so we can apply classification, clustering and regression separately. So, how to choose these tasks when the given problem is given. So, that is what we will be discussing today. So, in addition we will see few of the case studies of these problems, so that you will get a clear understanding of, so for a given situation whether I need to apply a classification algorithm or a clustering algorithm or a regression algorithm. Before proceeding into the topic, let us see few of the technological advancements that happen in our day-to-day life. So, if you consider Facebook, so when you open Facebook and post an image in your Facebook status, then automatically Facebook recognizes the people and it also even tags the people. So, this is your friend, this is his name, so and so, right. So, how this is happening, just try to think about that. So, and you must have seen in your mobile phones the Google Assistants, so which asks you, so shall I help you, or so if I see, so Google Assistant which recognizes your commands and responds appropriately to your commands, right. So, in addition to that, so in the e-commerce applications you must have seen the recommendation systems. So, when I search for a product, so the product recommends, the application recommends some of the additional products that are related to the product that I am searching for, right. So, what is the technology behind these kinds of applications? And if you consider the COVID, you must have seen the COVID prediction applications recently. So, Apollo has introduced this kind of application. So, given the lung scan of the patient or the person, so then this product will give the probability of the chances of getting affected by COVID. So, whether what are the chances that so the person is affected by COVID. So, these are all the kinds of recent advancements that we are seeing in the recent life. So, not only that, so the technological advancements in the predictive analytics, say for example weather prediction, so temperature prediction or the rain forecast or even traffic analysis and stock market prediction. So, all these are the kind of predictions that we are seeing in these days and the algorithms that are used in these analytics are working to the appropriate accuracy and how it is happening. And not only that, so the future is all about driverless cars. So, like when you want to reach a destination, so you just hire a car, so even without the driver, so the cab will take you to the desired destination. So, how it is happening? So, what is the technology that is being used in these devices? So, not only in the day-to-day life that we know, day-to-day activities that we know. So, there are certain applications, so the technology is being used, so which is not known to us. So, like given the CT scan of the person, so here it is a breast CT scan. So, the application itself is trying to identify whether the person is affected by any tumor or not, and if there is any tumor, then the application is trying to identify, so how many tumors are and what is the size of each tumor. All these are the all these are predicted by the application itself. And in addition, so you can see when you go on to the roads nowadays, the time given for the traffic signals is dynamic. So, that is depending on the traffic on the roads, so the timing for the signal is automatically changed, right? So that dynamically the timing of the traffic signals are being changed. So how this is happening? So Google is not only accepting our text data for searching, so it's also accepting speech data. So when you utter a word, so the Google automatically is retrieving all the web pages that are related to the word that we are uttering. So how this is happening? So what is the technology behind all these applications? So we should understand that, right? So it's very, very interesting. So the technology is taking forward our lives too much, and it's very interesting also. And if you consider almost all the websites nowadays, we are seeing the chatbots. So that is when you have an issue with the product, then so you can interact with this chatbot, and many of us even don't realize that we are talking to a machine, so not with the person, right? So the machine itself is interacting with us as if you will get a feeling that, so as if you are interacting with a human, not with a machine. So that kind of advancements are brought to the lives only because of the technology, right? And let's try to understand, let's try to discuss what is the technology behind these kinds of products. The technology behind all these products is a pattern recognition. So pattern recognition system is a technology which is basically trying to identify the patterns in the data, and the technology that is used to identify patterns in the data is called as pattern recognition. So the technology that is being used in all these applications is pattern recognition. So pattern recognition is identifying and analyzing the patterns in the data. So we humans, let's discuss for a while how we humans think. So given this text, so I can easily understand that, so I just read the text, right? Or given the image of the digit, so I can easily understand that it's a 2 or a 1 or a 0. So how can I understand that? So my eyes visualize the data, and my brain tries to analyze the patterns that are underlying in the data. So we humans learn the things by understanding or analyzing the patterns. So similarly, can we incorporate such kind of learning, that what humans are learning, can we incorporate that in the machines also? So can we make the machines learn the patterns in the data? So the technology is called as pattern recognition. So if you can automate the recognition of the patterns in the data, that is called as pattern recognition. And pattern recognition can be achieved in many ways, but recently machine learning algorithms, the set of complex algorithms so that are used to identify the patterns in the data, is called as machine learning algorithms. And with the help of the machine learning algorithms, so as it has seen so much success in the recent years, so it became so popular, right? So pattern recognition is basically identifying the patterns in the data, and the complex set of algorithms that are used to automate this process is called as machine learning algorithm. And throughout this course, we will be discussing various pattern recognition algorithms and various machine learning algorithms. Basically, I use the word alternately. So pattern recognition algorithm or the machine learning algorithm both refers to the same, so throughout the course. And now, so consider this example. So I am given the set of pictures here. So given this set of pictures, so when you are given, you are designing the pattern recognition system, so to classify these given set of images to male and female. So depending on the patterns in the data, so then the system itself will identify this person as a male and this person as female, and this person as a male and this person as female, right? So what the system is doing is, it's basically kind of classifying given set of images into males and females. Now let's try to understand, so how we humans learn. So we humans learn based on the experiences that we come across in the day-to-day life, right? And so if we can incorporate such kind of learning in the machines, that is called as machine learning. So if we can automate, like for example, so we humans can identify a digit, read the text and listen to the songs and analyze the text, right? So we can smell the things, right? So that kind of cognition can we incorporate into the machines also. So we can incorporate, if we can incorporate such kind of cognition in the machines, then it is called as artificial intelligence. So that is, you are making your machines to behave like humans, and such kind of intelligence in the machines is called as artificial intelligence. So is it possible to provide some kind of intelligence that is possible for the humans alone can be given to the machines. So if you can achieve that, that's called as artificial intelligence. And this artificial intelligence can be achieved in many ways, and one of the way is machine learning. So machine learning is basically one of the way to achieve artificial intelligence. And basically what this machine learning does is, it tries to identify the patterns in the data. So if the number is written like this, then I can say that it is 2. And if the number is written like this, then I can say that it is a 1, right? So that is, the pattern I am following in the writing is I have observed by the machine or the person. So that kind of identifying the patterns in the data is called as pattern recognition. And to identify the patterns, we are using certain set of algorithms called as machine learning algorithms. So let's see what is the difference between the traditional programming and the machine learning. So in case of the traditional programming, so like whatever you have done in the previous semesters, so you must have written a program for identifying the factorial of a given number, or addition of 2 matrices, multiplication of 2 matrices, or sorting of the numbers, right? So that is kind of the traditional way of programming you did in all your previous semesters. So let's try to understand, so what is the difference between the traditional programming and the machine learning. In case of the traditional programming, whatever you did in the previous semesters, what you did is, what is the input to your program? So you must have written the code to solve the problem, right? So that you are calling it as a program, and so you can consider that as a machine itself. So now you are providing the data as input, and also you need to write the code, and so both you need to give as input to your machine, right? And your machine will produce the output. Say for example, the factorial of a given number. So I need to give 5 as input, and also I need to give the set of commands. So meaning the for loop, whatever it is. So both are given as input to the traditional programming, and then so this will produce the output, and the output of the factorial will be given as output, right? So that's how the traditional programming works. But when it comes to the machine learning, so how it works is, so the data is the input, that is, you are providing some set of data as input to your program or the machine, and also in addition to that you are providing the output also. So try to observe the difference between these two. In this case, you are providing the input and the machine is producing the output. But in this case, you are showing to the machine kind of set of inputs along with the outputs, right? And then the program itself is generated by the machine. And the program is generated by the machine is, in the context of the machine learning, it is called as the model. So that is, you are showing to the machine a set of inputs along with the outputs. Say for example, consider the same example, the factorial example itself. What I do is, so I say 5 is the input and 120 is the output. Because, so for 5, 120 is the factorial. Say for example, for 4, so the factorial of 4 is 4 into 3 into 2 into 1, right? So it is 24. So again for 6, so I say it is 720. So likewise, so I just give some set of inputs along with the outputs. So I am showing this to the machine, and the machine will try to understand and analyze the patterns depending on the given input along with the output, and it produces a model. And later on, what you can do with the model is, so you can give certain numbers, say for example 10, so the machine itself will generate the output. So here you are not writing any kind of program, right? So to solve this factorial problem, you are not writing any program. So that's the beauty of the machine learning. So the difference between the traditional programming and the machine learning is, here in this case you are providing the input along with the program and you are getting the output. But in this case you are providing the input along with the outputs, and it is trying to, the machine is trying to analyze the patterns in the given data. So by observing few samples, and then it produces a program, what you call it as a model, and that model can be used to get the outputs for the given input later, right? So that is how the machine learning algorithms work. The learning is different, okay? So why should we use the machine learning or the pattern recognition systems is, so it makes our lives easy, right? Say for example, consider this classic example which is quoted in our textbook, prescribed textbook, that is pattern classification by Duda and Hartz. So the same example I'll be considering for throughout the course. So that's why I just wanted to explain the example. So this example is a famous fish classification example. So the task here is, so given the fishes, so you need to classify them into, so sea bass fish and the salmon fish. There are two different fishes, sea bass and the salmon fish. So given the fishes, so the objective is to classify or to separate them into two different bins. That is the task, and it can be done. It was used to be done manually, and when the humans involved, no, so it is error prone because there is a lot of tendency to make mistakes by humans because they get tired, right? So that there are many problems when it is done by humans, and that's why, so can we incorporate some kind of automation in that task? So what is the advantage of automating that task? So you cannot avoid humans, so that you can reduce the money, and also the correctness will improve as machines never makes mistakes, right, when compared to the humans. So these are all the advantages of bringing in automation in these kind of examples. So now let's consider how we can automate, and if we automate, how the machine works. So if we automate the fish classification problem, so what are the different stages that are involved in that problem? Let's see that. So now consider this is the conveyor belt. So you must have seen in airports or at least in movies the conveyor belt, where so whatever you keep the things on the conveyor belt, they will be moving, keep on moving, right? So like that, there is a conveyor belt and fishes are placed on the conveyor belt, and so when the fish, a particular fish is coming onto this panel, then its image will be captured by this camera. Okay, so the fish image is captured by this camera, and this camera is attached to a machine. So it's a computer, and inside this computer there is a pattern recognition algorithm or the machine learning algorithm, so which basically can identify the patterns in the data and will tell whether the input to this machine or the algorithm is the image, right? So already a well written model is developed and it is stored in the computer. So now when I provide this image, the fish image, then so the model will be executed, and what happens is it produces the output as whether the given fish image is a salmon fish or a sea bass fish. And then so this output is passed to a robot arm, okay, and we are designing a robot arm. And what this robot arm does is, which is a mechanical device, what it does is, so if the fish is, depending on the output that is produced by your model, so if the output is a sea bass fish, then this fish on the conveyor belt on this panel will be placed in this bin, because this is the bin for the sea bass fish. And if this fish is identified or represented by the model as a salmon fish, then this image will be placed in this salmon bin. Right. So now, so there is no human intervention. So it's everything is automated. So that is how you can use your pattern recognition systems for automating the real-time tasks. So even for the face recognition systems, you must have seen the face recognition systems. So like thumb impression systems, where you are using your thumb impression and getting identified, so who you are. Right. So you must have observed in your mobile phones, so opening your lock with the help of the biometrics, your thumb, or by giving your speech, or by giving your image as input, right. So these are all the applications developed with the pattern recognition algorithms itself. So there are plenty of applications. So everywhere we are using the pattern recognition algorithm, so knowingly or unknowingly. So it makes sense right now. So it's better to understand those technologies. So that is how we introduced this course on pattern recognition systems. So now consider this typical pattern recognition system. So how the typical pattern recognition system works. So already that example itself gives a clear understanding. So now let's see in detail how the pattern recognition system works. So like from the real world, so you need to collect the data, right. So you just collect the data from the real world. So and depending on the type of application, so you need to use the different machines, or so the data collection process varies. Say for example, your application is face recognition, then you need to use a camera. Say for example, if your application is a temperature prediction or the weather prediction, then you need to use sensors to collect the previous day's humidity or the temperature, or so like wind speed, all those things, right. So like that, depending on the type of application, so the way you are collecting the data changes. And say for example, it is something like video summarization. In that case, your input to the application is video. In that case, you should have a video recorder to record the videos, right. So that is how the way you are collecting the data from real world changes. Okay. So once you collect the data, then so you need the next process in your process is pre-processing and enhancement. So the need for this step is very, very important. So you cannot directly give the raw data. So whatever the data you are collecting from the real world, it's basically called as raw data. And this raw data cannot be given to your algorithms directly. So you need to apply some algorithms on that. So they are called as pre-processing and the enhancement algorithms. So why we should call them as, why we should apply these pre-processing and enhancement is, so when you are collecting the data, there is a possibility of missing some data, right. And also there is a possibility of getting some noise in the data. Say for example, when you are recording the speech, there is a possibility of getting the noise in the data, background noise. And also when you are capturing the images, there could be a problem of occlusion or the lighting or the brightness conditions or various other problems, right. So all these problems must be removed in the pre-processing and the enhancement stage. So once you apply the pre-processing and enhancement, so your data is now clean. So once you have the clean data, then you can apply what you call it as feature extraction. So we will see in detail what this feature extraction is, what are the various algorithms that are available for the feature extraction, but just try to remember. So we apply on the clean and processed data, so what we call it as feature extraction algorithms. Basically what this feature extraction algorithms does is, so whatever the type of the data you are giving as input, or whatever the data you collected, and after pre-processing, if you give it to the feature extraction algorithm, it converts to numbers, numerical representation, because whatever the type of data you have, that cannot be directly given to your algorithms, machine learning algorithms. So whatever the type of data, let it be speech or image or videos or simply numbers. So if it is numbers, directly you can give it to the algorithms, but as long as it is image, text or speech, some kind of processing must be done and it should be converted to numbers. And the process you are converting that data to the numbers, given the data to the numbers, is called as feature engineering. So that is called as feature engineering or the feature extraction. So in this case, you are converting your raw data or the given data, processed data, to set of feature vectors. That is in the numerical representation. So after that, once the features are ready, that is the data is now available in the numerical form. So that data can be passed to the applications. So if it is a classification problem, then you can pass it to the classification algorithm. So you just select one of the classification algorithm and then you apply. So again, depending on the type of applications and depending on many things, so what is the type of algorithm I need to apply, I should decide. So I should know, so whether I can apply this kind of classification algorithm or not, or depending on the given application, so you should be able to understand whether it comes under the classification or clustering or regression. So in this class, we will be discussing that in detail. So by the end of the class, you should be able to understand, so given the application, whether it comes under the classification or clustering or the regression task. And so given this problem, so you understand that, so say for example, so given problem is temperature prediction. Now I understand that I need to apply regression. So then after knowing the regression algorithm, but what is the type of regression algorithm I need to apply. So that also I should be able to understand, right. So That is how, these are all the steps that are involved typically in any of the pattern recognition system. So these are all the stages, you can say these are all the stages of your pattern recognition system. Okay. So now let's see what is a pipeline in your machine learning or the pattern recognition system. So this picture gives better details, some other details that are skipped in the previous algorithm actually. So that's how I have taken this. So now you are collecting the data from the real world, right? So let's call this as data, and this whole data, assume that you processed the data and you enhanced the data. So you applied all the techniques that are required to clean the data. Now the clean data is available and the feature extraction techniques are also applied, and now the data is converted into features, numerical form. Then what do I do is I divide the data into train data and test data. So directly I don't apply the algorithm on the entire data. What I do is I divide the data into train data and test data. So if you observe now, so train data is bigger when compared to the test data. So that is how you need to share the data. So most of the portion of the data that you have collected, so has to be considered as training data. So maybe a 20%, 15% or 25% of the data you should preserve for the test data, testing purpose. So why we are preserving this as a testing data is, so once your model is ready, so you need to get the performance measure, right? So like you need to evaluate your model, and how do you evaluate your model is only based on this test data. So that is, you are preserving a portion of your given data for the evaluation. So that's why you can even call it as evaluation data, right? So once you get this train data, what you need to do is, so you apply some model, and then so you start the training process on the data. So you can start the training process, and then you will be getting, so after applying the training on the train data, so then whatever you call it as the output of your machine is called as model, right? We already discussed that what model is. So the program that is generated by your machine, so after producing your data along with your outputs, that is called as model. So now the model is used for the evaluation. So now you try to evaluate the model performance on the test data. So try to understand this training data is used to create the model. Once the model is ready, then you need to apply the test data to get the performance evaluation of your model. So once that is done, so this model will produce the accuracy on the test data. So thereby you can understand that, so how your model is performing. So that is how, given the data, you need to get the share of the data as training data and the test data. And then on the train data, you need to apply the algorithm that gives you the model, and on the model you need to apply the test data that gives you the evaluation measures. And that is how you get the accuracy or any other evaluation measure depending on the application. And now, so let's see the workflow. So each of these figures, they are similar, but they give you different details. So that's why I am stressing on all these types of figures. So all are relevant, but each figure, it focuses on one specific point. So if you observe the last figure, so here this tells you various stages of your pattern recognition systems, and this next picture, this tells you, so how do you partition your data and what is model, and on which kind of data you need to apply the model, on which type of data you need to apply the evaluation. So then, so this picture gives you some more details of the pattern recognition systems. So now let's consider, we just collected the data, right? So from the from the real world, we are getting the data, and that data is called as a raw data, right? And then you need to apply the first step in your pattern recognition systems is the pre-processing. Okay, so this pre-processing, for the pre-processing, you can apply any of the pre-processing technique depending on your data or the application. Say for example, if your application is some kind of text processing, then you need to apply some kind of different algorithm, right? So if it is a video, then you need to apply some other pre-processing technique. So even if the text also, then again you have multiple types of algorithms, so you need to select one of these algorithm and try. So once your pre-processing is done, then what you get is called as a structured data. So on this structured data, so once you are happy with the data, then you can proceed to the next step. Right. So once you are not happy, if you are not happy with the data that is produced by your pre-processing algorithm, that what you are applying, then you can go back and then you can choose some other algorithm and apply. Okay. So that is how this pre-processing can be done iteratively. As long as you are not happy with the structured data that is produced by the pre-processing algorithm, you just go back, iterate, and then apply some other technique. So that is how you have to iterate this process. So somehow you get the structured data. Okay. So then once this data is available, so you need to apply some of the algorithm. So depending on the application, if it is classification, then some of the models you can apply. If it is regression, a different model you need to apply. So depending on the type of application, so you need to choose the algorithm from the available algorithms and then apply on the trained data. So whatever the data you are taking, no, so you partition that into training data and test data. So on the trained data you apply the model, and if you are happy with this model, so it generates a model, and if you are happy with the model, so then you can proceed to the next stage. Otherwise what you need to do is, so you need to again go back and change the parameters or choose some other algorithm and start learning process. So that is how again you need to repeat this process for number of times. As long as you are not happy with the model that is produced by the system, so you have to repeat this process. So if you are happy with this model, so then you can proceed to the next step. So in the next step what you need to do is, so you need to deploy your selected model in the real world, and that model we are calling it as a golden model. So the very reason is, so this is the model that is producing best accuracy, right, and that can be used for the applications. So this is how typically the workflow of the pattern recognition. So just to give the summary, so you are collecting the data from the real world, and that's called as a raw data, and you are selecting one of the pre-processing algorithm, and you are applying the pre-processing, and if you are happy with the data, then you can proceed, or otherwise go back and repeat the process. Then once your data is ready, so you take part of the data for training and some other data for testing, or so if it is a real world application you need not to do that. So then, so you select one of the model and apply the learning algorithm, some kind of learning algorithm depending on the application. So then if you are happy with the model, then okay, proceed to the next step, or otherwise repeat this process and change the parameters and learn the model. So this you need to repeat. If you are happy with the model, then proceed to the next step and deploy the selected model. So apply the model on the real time. So that is how the PR workflow is.